In this video, we would go over steps required for hypothesis testing using classical approach. So before we perform those steps, we have to first check the required conditions. The first is that the sample is a random sample, and the second condition is that n times p0 times 1 minus p0 greater or equal to 10, where n is the sample size, p0 is the value, proportion value in the claim, and then the third condition is that the sample size is less than or equal to 5% of the population size. So this gives us the independent, that the sample values are independent of each other. And actually, if you remember these three conditions, that would have the sampling distribution for this portion are approximately normal. Next we go to the steps. First step is that we have to determine null and alternative hypothesis. So null hypothesis always go with like this one, so P is equal to P0, right? So and it's denoted by H0. So if you see that, so if it could be two-tailed test, left-tailed or right-tailed, so null hypothesis is always the same, right? So that P is equal to P0. So actually alternative hypothesis, which one would determine that we are in two-tailed test, left-tailed or right-tailed. So in the two-tailed test, so this P would not equal to P0. And in left-tailed test, so P would be less than P0, and in right-tailed, P is greater than P0. It's really important that we correctly determine that what kind of test we are performing here, again based on the alternative hypothesis. Second step is that select the level of significance alpha. So it would be usually given in the problem. Third step is that compute test statistic with this equation. So C sub 0, that's test statistic. P hat, so this is proportion from the sample, and P0, that's proportion in the claim, and then you see N is the sample size. So after this step, so we have to compute this, use normal distribution table, or you can use calculator to compute the critical value z value. Say for example, if you have a two-tailed test and your alpha is 10%, so then it means that there are two tails, so 5% of the area would be here and other 5% would be here. If alpha is 10%, right? Because it's alpha by 2 here, you see that. So z sub alpha by 2 means that this alpha by 2 is the area over here. And similarly the same over here because of symmetry. And if it's like say left-tailed test and alpha is 10%, so then this value negative z sub alpha, so this would be here, that 10% area here, and 90% would be on the other side. The same here. So if it's a right-tailed test, so and alpha is 10%, so this area would be 10%. And we'd call this area colored green here. So that is actually called critical region. And these z values here, so in each, like two, if it's a two-tailed test, there are two critical values. If there's a left or right tail test, there is a one critical value here. The next thing we have to see is that this z value from step 3, so does this lie in this part here, in the critical region here, right? So, or it lies in the other, this yellow part. This yellow part is non-critical region. We have to determine this in the next step, so where this will lie. So in a two-tailed test, if z0 is less than negative z alpha by 2, so means that this value is here somewhere in the critical region, or z0 is greater than z alpha by 2, means that in this part here, right, then we would reject null hypothesis. For a left-tailed test, we would check that if z0 is less than negative z alpha, means that z value from step 3 lie in this region, so then reject null hypothesis. Similarly, for the right-tailed test, if Z0 is greater than Z alpha, meaning that Z0 value from step 3 lie in this region, so then reject null hypothesis. Right, so this will help us that whether we reject null hypothesis or not. So if it's not there, if Z0 value is not in this green region, right, this or this, right, depends upon the what kind of it's true-tailed, right-tailed or left-tailed test. So then we would not reject null hypothesis, meaning that if Z value is in the yellow region, right? So we would not reject null hypothesis then. So step 5, they state the conclusion. So it depends that we reject null hypothesis or not. If we reject null hypothesis, so it means that we would say there is enough evidence to support the alternative hypothesis. And if we do not reject null hypothesis, then we would say that there is not enough evidence to support alternative